AI image generators reduce noise variance by 80% in a single pass, pulling a coherent picture out of pure static. That's diffusion, the physics-based process behind tools like Midjourney and Stable Diffusion. By the end of this video, you'll understand how AI rewinds chaos to create images, why this approach beat older methods, and how tools like Comfy UI let you control the math instead of just guessing. If you are using AI to create, understanding this mechanism stops you from treating prompts like magic spells. Prompts are not incantations. They are instructions for steering the trajectory. This knowledge gives you leverage to fix bad outputs. If the hands look weird, you know the trajectory drifted, so you can guide it back, to control the workflow, to adjust the denoising steps, to actually generate what you want, instead of hoping for the best. When you understand this, you stop begging the AI for a better result. You start steering it. You probably think AI image generators work by scraping your prompt against a database of photos, stitching the best matches together like a collage. That would be like trying to bake a cake by gluing together crumbs from 100 different bakeries. It might look like a cake, but it would taste like a disaster. That is not how it works. The model does not store or remix images. It calculates a new path through mathematical space. Think of every possible image as a fixed coordinate in a vast, multi-dimensional map. This map contains every image that could ever exist. A noisy image is just that coordinate, wandering chaotically. Generation is the act of guiding that point, from chaos back to structure. Here is how the reverse path works. When you hit generate, you are not drawing or navigating. You start at a random, chaotic point on that map. At first, it looks like nothing, just snow on a TV screen. But that snow isn't random forever. It's waiting for a signal, and walk a precise path backward until you land exactly on the coordinate that matches your description. The text prompt is your compass. It tells the model which region of the map to target. The model calculates the steps to get you there. From the static, the model learns to reverse a chaotic system. It predicts the noise at every step and subtracts it. It's like watching a film in reverse. You see the smoke unburn, the broken glass reassemble, and the water flow back into the tap. That's what the model is doing with pixels, effectively running time backward. Your text prompt does not supply pixels. It acts as a constraint that steers that denoising path toward regions of space that match your words. But here's where it gets weird. The model does not just denoise. Your text prompt acts as a gravitational force that bends the entire trajectory. And in a second, I'll show you why this physics approach completely destroyed the old standard. The forward pass is easy to simulate. You take a clear image, systematically add random noise, until it is indistinguishable from static. The model learns this process quickly. The real magic is the reverse. The model trains to learn the exact inverse of that noise addition. It predicts the noise at each step and subtracts it. This reverse trajectory is mathematically equivalent to reversing time for a system undergoing random motion. By following this learned path, the model starts with a cloud of randomness and iteratively refines it until the noise resolves into a sharp picture. This method cuts noise variance by roughly 80% during key denoising phases, allowing the model to converge on a coherent image with remarkable speed. You are not getting a collage. You are getting a mathematically guided reconstruction. Here is why diffusion won. This architecture also solves the stability problems GANs faced, because the image exists as a noisy point at every step of the reverse process. You can pause, adjust, or modify specific areas without regenerating the whole thing. Techniques like inpainting work precisely because you are manipulating a point in space, not editing a fixed canvas. To appreciate why diffusion took over, you have to look at what came before. Generative adversarial networks, or GANs, dominated for years. A GAN pits two networks against each other. One tries to forge an image. The other tries to catch the forgery. The generator improves by constantly trying to fool the discriminator. It worked, but it was notoriously finicky. Training often collapsed into mode collapse, where the model would spit out the same image over and over. It's like a student who only memorizes one answer and gives it for every question. and the architecture lacked the mathematical stability needed for scaling. Diffusion emerged as a mathematically stable alternative. Foundational work began surfacing around 2020. Key refinements rolled out in 2022. These years solidified diffusion's theoretical footing, pushing performance past GANs. Then, in 2023, the technology hit the mainstream. Platforms like DALL-E, Midjourney, and Stable Diffusion became widely accessible, bringing diffusion-based generation to millions. Unlike the closed systems of the past, these tools were built on transparent workflows. Open-source models now give you granular control over every step. The stability is exactly why diffusion won, because the rival architecture had a fatal flaw that no amount of tweaking could fix. Once you see how stable this is, you will wonder how we ever lived without the ability to tweak the math directly. Here is how you take control. The black box reputation made AI hard to learn. You typed a prompt, read from item sense that, and got an image with zero visibility into how it was built. That opacity was a real barrier. It made it hard to learn or control. But the field is actively shifting from opaque generation toward transparent, physics-grounded manipulation. Workflow tools like Comfy UI are leading that charge. Instead of a single generate button, Comfy UI gives you a node-based workspace, where you can see and steer the entire pipeline. Think of it as swapping a magic wand for a set of Lego blocks. You watch data flow from the text encoder to the diffusion model, through the decoder, and out to the final image. This granular control lets you intervene at every stage of the reverse diffusion process. You can chain different models, apply custom operations, and adjust parameters in real time. Tools like this democratize AI literacy. They strip away the magic trick illusion and replace it with a visible, adjustable system. You are no longer just guessing. You are engineering the denoising path yourself. There is a reality check to accompany this power. Reverse diffusion is computationally heavy. Each image requires hundreds of sequential denoising steps, which demands serious processing power, and can slow down generation times. Optimizations are constantly shaving off that overhead, but the math still requires muscle. It's not just about waiting longer. It's about the computation needing more effort. The learning curve is also steep. While tools like Comfy UI make the process transparent, understanding high-dimensional spaces and denoising trajectories takes technical literacy. The gap between pressing a button and truly grasping the mechanics remains wide. You will need to invest time in the workflow to unlock its full potential. And the training data question has not vanished. Even though the model generates new images instead of copying old ones, it learns entirely from existing datasets. The model doesn't copy. It learns the style, the shapes, the concepts, but it learned them by studying the work of millions of artists. That tension between learning and copying is the debate that won't go away. That raises ongoing debates about data provenance and copyright. The industry is still figuring out how to balance open innovation with ethical training practices. It is a complex relationship between creation and replication, one you should keep in mind as you experiment. So when you generate an image, you are not asking a bot to find a photo. You are guiding a mathematical trajectory through high-dimensional space, using physics to pull order out of chaos, one denoising step at a time. Ink rewinds. Noise resolves. The image emerges from structure, not memory. We covered how AI rewinds chaos to create images. We saw why this approach beat older methods. And we looked at how tools like Comfy UI let you control the math instead of just guessing. The takeaway is simple. AI image generation is physics, not pattern matching. Mastering the denoising path gives you real control over the output. If you want this stuff explained without the hype, subscribe. That is what we do here, daily. That's the full picture. If this made it click, tap subscribe. There's a new AI explainer here every day, and tap the video on screen to keep going. See you in the next one.